Alright, so in this video, we're going to be looking at problem number 1 from 3.5. So this problem says to find dy by dx. Find dy by dx. And we have a function, y is equal to 1 plus x minus cosine x. Okay. We're also asked to graph the function because we need to understand the relationship between the graph of a function and the graph of its derivative. So dy dx, we're going to differentiate both sides. So d by dx of both sides, which is going to make this one just 1 times dy by dx, because we're looking at this implicit differentiation. And this is just going to be 0. So this is just going to be d by dx of 1, which is 0. So it's just going to be 0. Plus d by dx of x, which is just going to be 1. And we don't need to add a dx by dx because that's just going to be 1. And then minus d by dx of cosine x is negative sine x. So that's going to make this, let me actually just do this, negative sine x. And again, we don't need to add any sort of dx, d by dx, or any sort of term like dy by dx. And so this is just going to be what? Dy by dx is going to be equal to 1 plus sine x. And that is your answer. This is your answer right here. Now let's look at the graph. Okay, so this is 1 plus x minus cosine x and 1 plus sine x. So 1 plus x minus cosine x and 1 plus sine x. So these are the two functions. Now, I wanted to look at the relationship between the two. So this red graph right here, this is the original graph, or the graph of the function, the original function. This is the derivative. So this right here, this is the graph of the derivative. Now, if we look at a point like here, notice that the function is flattening out. And when this is flattening out, this portion here is going to have a derivative of 0. And as you can see here, this portion over here is at 0. So it's at negative pi over 2 comma 0. So the derivative is 0 at this moment. And here, when we see that the derivative is, or the slope is positive, we're above the axis. Now, it's always going to be positive here in this graph, and so that's why the graph of 1 plus sine x is always above the x-axis. It's going to hit 0 sometimes, but so for example here, as we keep zooming out, it's kind of like a wiggly function. Both are wiggly functions, but this one, it's a wiggly function. It's going to occasionally be flat, and that's when we're going to hit the zeros, okay? So whenever it's flat, you're going to have a 0 on the 1 plus sine x, 1 plus sine x graph. Typically, when you're graphing this on paper or when you're hand drawing this, you would draw only like a section of this. Like for example, maybe this box right here. This is a portion that you would do, for example. But in this case, we can see on Desmos that it's going to work all the time throughout how much ever we zoom out. Okay, so that's just this function right over here. I hope you found this video helpful.